Welcome back to the Deep Dive. Today we're digging into Anthropic's latest, Claude Sonnet 4.5. We've got the docs, the benchmarks, all the notes, and our mission is to really give you the inside track on this new model.
Yeah, absolutely.
Because look, this isn't just some minor update they're pushing out. The way Anthropic is framing it, this is meant to be a pretty major step forward, especially for things like coding, complex agent behavior, and reasoning capability.
That's right. It's positioned as let's say, a drop-in upgrade for Sonnet 4. But the real focus, the engineering push, it's all about making it smarter, more capable in those key agentic areas. They really want this to be the go-to model for complex autonomous tasks.
Okay, makes sense. And for anyone listening who's thinking, all right, when can I try this? How accessible is it right now?
Oh, it's quite broad already. You can get it through the main Claude API and their platform, obviously. But critically, it's also rolling out on the big cloud platforms. Think Amazon Bedrock, Google Cloud's Vertex AI.
Right, so it's not some lab experiment. It's geared up for enterprise use pretty much immediately.
Exactly. They're aiming for wide deployment.
Okay, so let's dive into the tech. What's the big leap here? The sources really hammer on coding ability first. Is it just, writing snippets better, or is it more fundamental?
It's definitely more fundamental than just code completion. They're reporting a really strong score on the SWE-bench verified benchmark, 77.2%.
SWE-bench verified. Remind us what that actually tests.
Right, so SWE-bench isn't about writing new code from scratch. It measures how well the model can find and fix real bugs in existing complex open source projects, like proper messy code bases. So a high score there suggests it's good at understanding architecture, reasoning about security implications, and keeping track of things across lots of files when it's trying to fix something. It's about deeper understanding.
Okay, that's a big deal for maintaining complex software. But agents need to do things, interact with tools. You often see these models get stuck doing one thing, waiting, then the next thing. Very step by step. Anthropic is talking about parallel execution. How significant is that shift?
Oh, it's foundational. Absolutely huge for making agents actually, efficient.
Yeah.
The sources make a big point that Sonnet 4.5 isn't stuck in that old sequential mode. It can coordinate multiple tools, run different operations at the same time in parallel.
Can you give an example? Like, how would that play out?
Sure. Think about maybe managing a complex server update. A typical model might be like one person doing everything. Check the logs, then download the patch, then apply it, then run tests. Super slow. Sonnet 4.5 is more like a supervisor. It could be, say, reading the security vulnerability report, running a couple of shell commands to check system resources, and starting to write the unit tests for the patch, all concurrently.
Wow, okay.
Yeah, it dramatically speeds up tasks that have lots of independent little steps.
Okay, hang on. Parallel sounds great for speed, but doesn't that increase the risk of, things going wrong? If 5 things are happening at once, how does he keep them straight?
That's exactly the challenge, yeah. And that leads right into the next key feature, self-verification. It's got these internal feedback loops. The model doesn't just execute the plan and hope it worked. It actively writes little checks for itself along the way.
What kind of checks?
It might generate small test scripts or run commands to verify the output of one tool before it feeds that output into the next step, especially with those parallel operations. It's like building its own little safety net as it goes.
Right.
Which, theoretically makes it much more reliable for long, complex jobs.
Right, reliability. And that ties into something else mentioned, better prompt adherence or steerability. Is that just jargon, or does it mean it actually follows instructions better?
Right.
Less wandering off.
Less wandering off is a good way to put it. No, it seems genuinely improved. If you give it very specific instructions like only output JSON format or check service X before restarting service Y, it's much less likely to ignore parts of that or add extra commentary.
Which is crucial if you're automating something sensitive, I guess.
Absolutely. Precision matters for automation. You don't want the agent getting creative when it's supposed to be following a strict protocol. Less verbosity, less drift.
Okay, let's switch gears a bit. The big bottleneck for complex, long-running AI tasks has always been memory, right? That limited context window. What's Anthropic doing about that?
Yeah, the context ceiling. It's a killer for long horizon stuff. They've introduced something new called the memory tool, currently in beta.
Memory tool, is that just a bigger context window or something different?
No, it's architecturally different. It's not just more scratch paper. It's a mechanism designed to let the agent store important information outside of that main active working memory.
Ah, okay. Like a separate notebook or database it can refer back to.
Exactly. Think of it as persistent storage. a long-term journal. So if an agent is working on, say, a massive project audit over 3 weeks, it can stash key findings, decisions, or context points in this memory tool. Then later, even in a new session, it can retrieve that info without having to cram everything back into the active context window, which is usually expensive token-wise. It enables continuity.
That sounds potentially game-changing for tasks that just couldn't fit before. How does it manage what goes in the notebook versus what stays in active memory?
Well, that's where the related context management features come in. The model can now do context editing and trimming. As it works, it can identify bits of the conversation history or tool outputs that are basically resolved or no longer immediately relevant and prune them out to save space.
So it tidies up after itself.
Kind of, yeah. It tries to keep the essential thread going, but cuts out the old clutter. And importantly, it also apparently monitors its own token usage. It tries to anticipate hitting the context limit and reorganize things, like maybe summarizing older parts or pushing stuff to the memory tool before it runs out of space. Smarter resource management.
Okay, interesting. Before we get to applications, we have to talk safety. They claim Sonnet 4.5 is their most aligned model yet. What does that mean in practice? What's actually safer?
Right. Alignment and safety are always critical. They're reporting lower rates of the usual bad behaviors, things like making stuff up or hallucinating, being overly agreeable or sycophantic, and crucially, deception. Fewer instances compared to older models.
Okay, standard improvements. Anything specific?
Yes, and this is where it gets quite specific. They talk about upgraded defenses against prompt injection attacks. That's a huge deal if you're letting an agent interact with external systems or user inputs. And they've also specifically improved the classifiers for detecting harmful content requests, especially in really high-risk areas. They mention CBRN threats, chemical, biological, radiological, nuclear.
Wow. Okay, so really hardening it against misuse in dangerous domains.
Exactly. It's about making sure that as these models get more capable, the guardrails get stronger too, especially for enterprise or widespread use.
All right, so we've got better coding, parallel actions, self-checking, persistent memory, stronger safety. What does this actually look like when it's put to work? Any concrete results or benchmarks for real-world stuff?
Yeah, they shared a few interesting points. On the OS World benchmark, which tests how well an agent can use a standard computer OS, like manipulating files, using apps, it scored 61.4%.
61.4%. How good is that, practically speaking?
It means it can successfully complete, almost 2/3 of those kinds of common computer tasks autonomously, which is pretty decent, shows potential for genuine desktop automation.
Okay, benchmarks are one thing. What about, like, sustained use? Any anecdote?
That's where it gets really compelling. The sources mention internal tests, where Sonnet 4.5 apparently ran for over 30 hours straight, working autonomously on coding tasks.
30 hours. Continuously.
That's what they observed, yeah. Which really speaks to the memory and self-correction working together over a long period. And in other enterprise trials, they saw it do things like set up entire systems, autonomously provisioning cloud services, doing audits, even buying domain names.
Seriously.
Yeah.
Buying domains.
Cleverly so. The qualitative feedback seems to be that it feels faster, more predictable, less flaky, and particularly good when dealing with tasks that involve lots of different files or systems needing to stay consistent.
Okay, so let's tie this together for the listener. If you're thinking about using this, where should it really shine? What are the prime use cases?
Based on all this, you can sort of group them. First is agentic or autonomous systems. If you need something to manage a complex multi-step process from end to end, coordinating different parts, this looks like a strong candidate.
Right. Makes sense. What else?
Second, end-to-end software development. Not just suggesting code, but actually helping with architecture, planning big refactors, reviewing large code bases, being more of an integrated development partner.
Okay. Third.
Third, workflow automation. Stuff like reliably working with spreadsheets, pulling data from websites, managing files, even driving UIs for browser automation tasks that have often been brittle with older models.
Got it. And the last one.
And finally, domain-specific analysis. Because it can handle more context and reason longer, it seems well-suited for complex, knowledge-intensive fields. Think financial modeling, detailed compliance audits, cybersecurity analysis looking for vulnerabilities, areas where deep context and accuracy are paramount.
Those are some pretty powerful applications, but we need that critical lens too. What are the catches? What are the risks or limitations that the sources mention we need to watch out for?
Definitely important to cover the caveats. The first big one is token burn. All that parallel tool use and self-verification, it's great for getting the job done right, but it eats through tokens really fast.
Right. Tokens cost money. So more capable means potentially much more expensive if you're not careful.
Exactly. Every check, every parallel action, every reference to that memory tool, it all adds up on the bill. Managing the trade-off between thoroughness and cost is going to be key.
What else?
Second potential issue is over-engineering. Because it can build these complex checks and scaffolds for itself, sometimes it might build something way more complicated than necessary. Creating helper scripts and elaborate verification steps when maybe a simple fix would have worked.
So the AI might create unnecessary complexity that a human then has to understand and manage.
Precisely. You could end up spending more time debugging the AI's elaborate process than you would have spent on the original problem if you're not careful.
Okay, that's a good warning. Any other major limitations?
The third one ties back to that new memory tool, memory and state drift. It's a fantastic idea, but ensuring that the information stored in that long-term memory perfectly aligns with the current state of the world or the active context, especially after weeks or months, that's a really hard problem.
So the memory could become outdated or slightly inconsistent with reality over time.
It's a risk, yeah. Maintaining that long-term coherence and correctness is still a major research challenge. And we also have to remember, benchmark performance doesn't always translate perfectly to messy, real-world scenarios.
Right. The real world is always more complex.
Uh-huh.
Okay, so this brings us to strategy. Given the power, but also these significant caveats, how should people actually approach using this? What's the smart way to start?
The advice seems pretty consistent. Don't just flip the switch to full autonomy on day one.
Start cautiously.
Exactly. Begin with hybrid workflows. Use Sonnet 4.5 as a powerful assistant, where a human is still validating the key steps and outputs, especially for complex or parallel tasks. Then gradually increase autonomy as you build trust and understanding.
And keep a very close eye on the costs, I imagine.
Absolutely critical. Monitor that token usage. The pricing mentioned is 3 per $1 million input tokens, 15 per $1 million output tokens. That can escalate quickly with complex agentic loops. But and this is important, the source is heavily emphasized using techniques like prompt caching and batch processing. They claim those methods can cut costs by potentially up to 90%.
90%. Okay, that's huge. That makes it viable.
It makes it much more viable, yes. You need to be smart about implementation.
And what about for those really critical areas like finance or security?
There, the advice is clear. Build your own external safety nets. Don't rely solely on the model's internal self-verification. Add external validation layers, custom guardrails, human review points. Basically, trust but verify rigorously.
And benchmark it yourself. Make sure the performance gains actually apply to your specific problems.
Couldn't have said it better myself. Internal benchmarking is essential.
So, wrapping this all up, what's the core takeaway here?
I think the main point is that Sonnet 4.5 represents a really significant step up in what we call agentic capacity. It's about the model's ability to plan complex tasks, check its own work, and operate effectively over much longer timescales using that memory. It's pushing AI much closer to genuinely autonomous computer use.
It definitely feels like a shift. Which leads us to a final thought for you, the listener, to ponder. Given this new persistent memory tool and the model's tendency to sometimes build complex scaffolding for itself, what's the best strategy for a human operator to actually monitor, debug, and ensure logical consistency in a system that might have been running autonomously for weeks, even months? The tech is advancing, but our methods for overseeing it need to evolve just as fast. That's something to think about. Thanks for diving deep with us today.
My pleasure.
We'll catch you on the next one.